And in your Block 6 table of contents, Lesson 1 is equations. For graphs and tables. Today's 10:26. Okay. Let's look at this first one. Number 1, Shakira makes and sells necklaces. She has saved $40 and she will earn $20 more each week. How much money will Shakira have in 3 weeks? So if you look at the graph, it says she's saved $40. That means after 0 weeks, she's already got $40. So that's why the graph is hiked up to 40 at the start. And then she will save $20 each week. So the graph is going up $20 the first week and up $20 the next week and up $20 the week after that. So 3 weeks would be $100. You could also think of it like, hey, after 3 weeks of saving $20 a week, she saved $60, but she already had 40 in her bank. So the 40 she already had plus the 60 she got over those 3 weeks adds to 100. The big thing that we're focusing on today is how do we write an equation for a graph like that that's hiked up a little bit. So let's break that down. Number 2, Juliet and Mimi each start a food truck business. Mimi has $500 to start. They each draw business plans showing a profit of $250 per day. Express Juliet and Mimi's earnings with equations. So the only big difference between Mimi and Juliet is that Mimi already had $500. Juliet started out with nothing. And we can see that difference in the graph because Juliet started out with nothing but goes up $250 a day. Mimi started out with $500 and still goes up $250 a day. So it wants us to find some values. For Juliet's graph, we've got 0, 0, and we've got 3, 750. On Juliet's graph, when we've got an x-coordinate of 0, meaning 0 days, we've got a y-coordinate of 0, meaning she didn't have any money. Then when we've got an x-coordinate of 3, meaning 3 days, the y-coordinate is 750, meaning in 3 days she's got $750. For Mimi's graph, we've got the coordinate 0, what? 500. And then 3 comma what? 1250. So step 2 says describe the patterns. Well, a pattern that you see that would fill in the blanks here is that Mimi always has $500 more than Juliet. When they started, Mimi had a $500 difference. And even after 3 days, Mimi still has $500 more. The rate, that's just how much money they're earning per day, and it says that all the way up here, they're earning a profit of $250 per day. We can also see that as the graph jumps up for both of them, $250 each day. So the rate is $250 per day. So here's how we get the equations. For Juliet, this is just like what we were doing in the last block, where if she's earning $250 per day and she didn't have anything to start with, the equation would be y equals 250x, where y is the total profit she's earned, and x is how many days she's been working. For Mimi, she's also earning $250 a day. So I think we also need a y equals 250x for hers. But how do you, oh, don't flip that paper over quite yet. How do you think we signify that Mimi had that $500 bonus? Just write plus 500. That's the only difference in those two equations. Whenever you've hiked the graph up by $500, you just put plus whatever that is. Any questions on that? Okay, let's flip the paper over. Ayla and Mina are making phone cases at a tech fair. Mina has made 12 cases when Ayla arrives. They each make 3 phone cases per hour. Express the number of phone cases Ayla and Mina make as equations. So, for Ayla, at time 0, she's not made any cases because she got there a little late. And at the 3-hour mark, she's made 9 cases. Mina got there a little early, and so at the time that Ayla arrives, Mina has already made 12 cases. And at that 3-hour mark, Mina has 21 cases total. Now, each of these people is making 3 cases per hour. We see that on both graphs by the fact that each of those dots is increasing by 3. So jumping down to step 3, the rate is 3 cases per hour. However, Mina is always 12 phone cases ahead of Ayla. So the equations that would best describe this, for Ayla, she just makes 3 cases per hour. The number of cases she makes is equal to 3 times the number of hours she's been there. For Mina, she's also making 3 cases per hour, so y equals 3x. But then we add a plus 12 on the end, because by the time Ayla got there, Mina had already made 12 cases. How are you feeling on that? Okay, can you try number 4? haven't already, take a moment to check your work up here. So based on those graphs, it looks like Todd is always 25 miles ahead of Chin. He got a little 25-mile head start, but they're both driving at 50 miles per hour. So both of their equations would say y equals 50x, but Todd would say y equals 50x plus 25. Any questions? Okay, let's look at this next page, which is basically the same thing, except instead of looking at a graph, we're looking at a table. So, Tim and Louisa are testing a new two-person kayak for their rental business. Tim is sitting 3 feet in front of Louisa. What are Louisa's and Tim's distances at 5 seconds? So, what's kind of tricky about this one is the times are going up by 1, and then 1, and then 1, and then 2. So we're missing the 4-second mark, so be careful on that. But looking at the change, we've got Louisa going up 2 feet, and then another 2 feet, and then another 2 feet. So it looks like Louisa is moving at a rate of 2 feet per second. For Tim, he's also going up by 2 feet and 2 feet and 2 feet, which should make sense because they're in the same kayak. So they've got to be moving at the same speed if they're in the same little container or vehicle. But Tim is always 3 feet ahead because he's sitting in front. So Louisa, we could just write the equation y equals 2x, and for Tim, we could write y equals 2x plus 3, right? The reason I want to do it that way is because the table, it's not that hard to get the 5-second mark, but because we're skipping that 4-second mark, it might be easier to just make an equation and plug some values in. If we want to know their time, or excuse me, their distance at 5 seconds, plug in a 5 for x. What's 2 times 5? So Louisa is 10 feet from where she'd started. Do the same thing for Tim and say 2 times 5 plus 3. Careful in your order of operations here. Do the multiplication first. 2 times 5 is 10. 10 plus 3 is 13. So after 5 seconds, Louisa is 10 feet from where they had started, but Tim is 13 feet. From the table, you can see that they're going up 2, but then that last jump is up 4. That's because really they're jumping 2 feet per second. But that last jump in the table is 2 seconds. So if you double the number of seconds, you should double the number of feet, right? Okay, let's try that again. Ed and Inez are moving a new entertainment center on a hand truck into their furniture store. Express Ed's and Inez's distances with equations. So, at time 0, Ed has moved 0 feet. But Inez looks like she's on the other end of that entertainment center, so she's 5 feet ahead. After 1 second, it looks like both of them traveled 7 feet. After another second, it looks like both of them traveled 7 feet again. But then it jumps from 14 to 35 and from 19 to 40. Well, those are increases of 21. But they didn't just start sprinting 3 times as fast. It's because that last jump in the table is 3 seconds. So 7 feet every 1 second or 21 feet every 3 seconds still comes out to 7 feet per second. Now over here, this is what it wants us to do. I'm not going to do any of that. I think we're pretty safe to say that Inez is always 5 feet ahead of Ed. Right? So if they're both moving at 7 feet per second, but Inez has a 5-foot head start, how would I write Ed's equation? If Ed is moving 7 feet per second, just y equals 7x. How would I write Inez's equation to say, hey, she's also moving 7 feet per second, but she's got a 5-foot head start? Yeah, y equals 7x plus 5. Let's do one more together. Ming and Zach both charge the same hourly rate to rent out their food trucks, but Zach charges a cleaning fee. Express Ming's and Zach's charges with equations. So let's look at the change to figure out the rate. After 1 hour, it looks like both of them charged $24. 0 up to 24 is an increase of $24. And 45 up to 69 is also an increase of $24. But then 24 up to 72 is an increase of $48. 69 up to 117 is again an increase of 48. 72 up to 120 is an increase of 48. 117 up to 165. If you subtract 165 minus 117, you'll see a difference of $48. So what's their hourly rate? Is it 24 or 48? What do you say 24? Because what? Because they're skipping. Yeah. From 0 to 1 hour is just a 1 hour difference. But from 1 to 3, they're skipping up 2 hours. And 48 divided by 2 is 24. From 3 to 5 hours is again skipping up 2 hours. 48 divided by 2 is 24. So the rate is still $24 per hour. So they just gave us weird random snapshots of different times rather than just 1 hour, 2 hour, 3 hour, 4 hours. Help me fill in the blanks. Blank always charges blank more than blank. Perfect. I heard Zach always charges 45. More than Ming. So if Y stands for the total cost, the total charges to rent those food trucks, how would I write an equation for mean? Y equals 24x. The total cost is equal to $24 per hour. What about Zach? Perfect. Y equals 24x plus 45. Zach charges $24 per hour plus a $45 cleaning fee. Okay, please try that last one with Paco, a water skiing instructor, and Kate. Anybody feel weird about that last one?
No.
I do, because it says that they're moving at a distance of 8 feet per minute. How do you water ski 8 feet per minute? Like, that's from here to here in a minute? Somebody sounds boring. Y'all ever gone water skiing? You better go faster than 8 feet per minute, or you're just going to be like gently towing along in the water. You wouldn't even be actually skiing. You would just be kind of like holding on to the thing, being dragged very slowly. Y'all have any questions? Okay, grab your computers, please.